Coming back to the parametric design patterns that I've been looking at, popularized by Robert Woodbury, looking at the GoalSeeker, which is a more complicated pattern, at least for execution in Revit or Vasari, because it takes some amount of sort of iteration through the model, sort of multiple passes. So what it looks at is it looks at taking a certain input, doing some transformation on it, measuring the output, and then going back through the cycle again until you hit a certain threshold. And here is the sort of the simplest way of looking at it, of having a line on another line that's intersecting it and having it march along that line until it passes by it, and then go back and get closer and closer and closer until you're essentially right on that line. And there's other examples of that, sort of, there's like the classic hill climbing, where you have a point that tries to find a local maximum, that sort of thing. But what I want to look at is this sort of simple idea of having something that just seeks, or this simplified relationship between an intersection of one line and another. Here it's going to go so fast that it's almost not interesting, but it's good just to sort of show you the basics of how this works. So the way that I'm getting this to work is actually using the Revit Python shell plugin that I showed in another post, that has a relatively simple script that goes through and does just what I was describing before, which it goes and it sees if it makes a change to a model, sees if it has passed over the threshold, and makes adjustments based on whether it has reached or not reached that goal. This is written by my friend Aki, who has been kind enough to whip up this little script. It happened very fast. And the thing that's interesting in Revit and Vasari about this is that you can apply this same script to a bunch of different models. Here, what I'm going to show is I've got the simple line intersecting another line. I've got one sort of input which pushes this point along the line, this h1 value, this h1 parameter, and then this is a reporting parameter which is just going to tell the output of what that is. If I change this, it's going to have a resulting here. So if I look at the properties of this, you can see that I've got h1, which is set to a certain value, and I've got v1, which basically just says the result of this change. And then there's the parameter goal. So three pieces, h1, v1, and goal. Goal is what I want v1 to become. So I'm going to make changes to h1, it's going to have a resulting change in v1, and it's going to be measured against goal. So here, I'll just run my script really quick. If I go to my add-ins, I'm going to grab my Revit Python shell and just pull it out here. And I've got GoalSeeker, GoalSeeker 2. I've made some changes to it. So I'm just going to run it, and remember it's looking for 0. So off it goes, thinks about it for a second, bam, and it's on the line. Now, it gives me some outputs. It says that the goal was 0. It says that it reached it, and what the difference was. It's off by a very, very, very small number. That's the goal, that's what it ended up as, and that is the difference between the two. And the number of iterations that it took to get there, one iteration. How to do it in one iteration? The code is actually pretty smart. It does a pre-guess, where it has two guesses very close to each other, and then does some determination to adjust that guess of how far it should move. Now here I've got a linear relationship, so it's able to guess very accurately on the first time. So you can see how else it works. If I change this goal to 10 feet in my parameters, and now I run it again, it's going to go bang to 10 feet over here. And again, it did it in one iteration. So this is not the most fun one to look at. So we can start cranking up the complexity of this and see how it goes. So we can do, no, I'm going to wait on this one. We'll go to that one in a second. We can go with this one, where you don't actually have a linear relationship. What I want to have is this one is set up so that I'm going to change h1 again, and it's going to make some change to v1, and it's going to be gold on something else. So I've got h1, same thing, where I'm going to change this input, and it's going to result in a change here, which is it's not a straightforward relationship, it's an angular relationship. And the goal is actually something that's also a little bit more complex, where it's 2 times this distance. So in the end, what I want to do is I want to push this point along until this line is twice as long as the point from here to here. So it gets a little bit more complicated, and so it's going to have to do a little bit more thinking when it runs through this. So I'm going to run my GoalSeeker again, and it's going to start moving this guy, and I'm going to get slightly off axis, which is fine, and it's going to move that point around. Took 4 iterations to get it this time, and again with a huge amount of accuracy to what I wanted. See, I've got 31 feet, and this is 15.6. So you know, I can change what that is. I can make this, you know, 1.5 of that, and then run my GoalSeeker again, and it'll push that point around. It doesn't have very far to go. There it is. Again, very high degree of accuracy, 4 iterations. So even that's all well and good. So, and again, I want to just illustrate that I haven't changed my script at all. I'm just changing what my parameters do to each other. So now I've introduced sort of there's this non-straight relationship. So let's get something even stranger. Let's see. We'll do one more of these guys. So I've got same kind of thing, except it's pushing the line along a curve. And again, I've got pretty much the same parameters. And I can do it. And this is just a little bit more of a challenge for the calculations to run. And you can see it's going to run through it. There it goes. It's walking along the line. It takes 5 iterations. Big deal. So the next thing I want to show is when you get into things like volume. Just to sort of show you that it doesn't need to just be feet. So here what I've got is I've got a basic cube that, again, you can see my h parameter. Here my h parameter is doing the whole cube. All 3 dimensions on it are driven by that h parameter. They're going to all be cubed to come up with a cubic feet. So I'm doing a volume calculation, and I can goal this to be a cubic foot calculation. So I've got 16 cubic feet, and I'm going to do it again here, and this is where, you know, it's going to start pushing this guy around, and it's going to find its place. There we go, 5 iterations. And if I go and I say, no, I don't want 16 cubic feet, I need 1,000 square feet. This 1,000 cubic feet. Let's give it something weird. 1,003 cubic feet. And I can GoalSeek that one, and you're going to see it jumping around. It's going to probably do a couple more jumps because it's having a significant change in size. And there we go. It took 10 iterations this time to get up to that goal, and something's not right here. Let me just see. GoalSeeker 1, 10 iterations. Here's the thing. Okay, so now you can know it's live because there are mistakes. So what I did here is I'm looking at my code, and I have a maximum number of runs, and I have the maximum number of runs set to 10, and the epsilon, which is how accurately I want it to hit my target, is set to a very small number. And I can see in my output that I have gone to 1,564, which has a difference of 561 from my target. That's not good. And why did it stop there? Because it did 10 iterations and then it stopped. Well, all I have to do here is I have to just change this. So let me give it 20 iterations. And I'm going to go save. And I can just run my script again. Let's get a little closer than 10 iterations will allow. Now it only took it 5 iterations, but now you can see that it has smacked right onto 1003. So we're all good. So now that we've got these sort of abstracted situations done, let's crank it up one more notch in complexity. So I've got, this is still pretty abstract and not a real workflow, but you'll get the idea. So let's say I've got my site plan here, and here's my plot, which is this line right here. And I need to put a building here on this site, and I need it to be X number of square feet of usable space. So I've got a family here that has these same parameters in it that we've been seeing. I've got my H value, but I've also got an H2 and an H3. Now what I've done is I've hooked up H1, and I've got my V1, and I've got my goal still, right? Well, H1 is going to actually drive a proportional system. So I've got my height of my building, but my height is going to be linked up in a proportional system to my width and my length. And that is all going to be multiplied together to give me a volume, which is very similar to the cube that I was showing before. I've got H1 times H2 times H3. But then I'm going to divide them by my floor height, which is going to give me a square footage. So I can basically dial up how much square footage I want, and it's going to give me a cube that works with my proportional system to come up with that appropriate size. So let's say I need 100,000 square feet of nicely proportioned box. Okay. Well, I've got my box, and I'm just going to run my GoalSeeker, and we'll see what happens. Off it goes. Boink, 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 boink. Takes 9 iterations. It comes on smack dab right on the goal. And so now I can load this back up into my project. I can overwrite the existing one. And maybe I want to just rotate it so it actually fits here. There. Close enough. And one thing is probably going to have a slightly more square footage than I want because it's got one floor area that's right up there, but let's take a look. We've got a mass that has yep, it has slightly more than 100,000 square feet because it has one more floor on it. But you know, as you can see, that floor is, you know, not that's a place where you're going to put your gerbils. So if I go in here and I look at it from the side, I can take out that last floor, which doesn't really do anything. And there, I've got pretty smack dab right on 100,000 square feet based on my building that has my proportional system. And I didn't even have to think about it. Anyway, there are a lot more examples to be done with this, but basically I just wanted to show you how you can take one sort of piece of heavy lifting engine and apply it to a number of different things just using standard Revit tools and formulas. And I hope that was helpful and understandable. Thanks.